Welcome to the lecture on principles of equivalence. So, we in the last lecture discussed about the equivalence concept, and we had seen that how one of the factor is to be calculated. The three elements which are required for the equivalence calculation is the amount of sum, then the time of occurrence of the sum, and the interest rate. So, basically when you have a cash flow, also we saw that in the cash flows type of situations, you have to find the equivalent value at a different time, and for that you need to have the value of these factors, the compounding factors which we have seen, many type of factors are there. So, these factors are to be used, and then accordingly you have to find the equivalent value at a particular time. So, if you are finding the values at a particular time, you can add or subtract these numerical values at that particular time. The transactions which are occurring at different times cannot be directly added or subtracted. That is what is there in the case of equivalence. Now, when we talk about the two type of cash flows, and we are to ascertain whether the two different cash flows are equivalent or not, again you have to put the equivalent principle, like that if you have a cash flow which talks about the present value of something like 300 rupees, and then you have a cash flow which talks about the future value of maybe 798 rupees. Now, whether they are equivalent or not, and if the time period is given as 7 years, so for a particular rate of interest, they will be equivalent. So, that if this present value of 300 at that particular rate of interest gives you the future value of 798, maybe at the end of 7 years, then they are said to be the equivalent cash flows. Like that what we have understood by looking at the cash flows. Now, we will talk about other principles of finding the equivalence, and now one of that principle is that at any point in time, since it is known that for one cash flow to be equivalent to another, their equivalent values must be equal at any point in time. So, basically this is one of the equivalence principle, that if your one of the cash flow is said to be equivalent to another, in that case at any point of time, if you find the equivalent values, they have to be equal, and for that basically we had seen that case of the two cash flows. Suppose one of the cash flow, as we discussed, that it is giving you the present value of 300 for 7 years of time, and in another case you have the future value, and this future value is coming as 798 rupees, and it is again giving you the time of n equal to 7. Now, if they are equivalent, then if you take at any point of time, if you find the values, they must be equal. Now, the rate of interest is 15% and time is time is 7 years. So, this principle tells that if you try to find the equivalent value at any point, for these two cash flows, they must be equal at any point of time. So, if you suppose extend this to any particular time of suppose say n equal to 10, in that case if you take go to this n equal to 10 in that case, and this also is suppose taken at n equal to 10. Now, for this 300 has to be multiplied with p by f. So, this will be f by p and 15 and 10, and similarly this 798 has to be multiplied with, it is only going to 3 time periods. So, it will be again f by p 15 3. Now, it will be basically 4.046, and this will be 1.521. So, both the both these result into the value of 1214. So, something like that you are going to get if the two of the cash flows are equivalent at any point of time. If you find the equivalent values, they are supposed to be equal. Now, so we can say that two or more cash flows, if they are equivalent, if they are and if you have two cash flows, and if one of the cash flow is equivalent to one of the this cash flow, then certainly that cash flow will also be equivalent to this particular cash flow. So, if the two are cash flows being equivalent and one of them is equal to another cash flow, then they also will be equal to the other one. That is also again no need to be discussing further about it, because that is very clear that if 1 is equal to 2 and 2 and 3 is equal, so 1 will be the same as 3. Now, a very interesting situation occurs in the case of these financial transactions, that many a times during the different time intervals you are faced with different interest rates. So, maybe that if you have a time horizon of 10 years, maybe for initial 2 years you may have a case of 10% compounded annually, then second to fourth year it may go to 9%, then from 4th to 6th it may go to 8%, like that. So, you have many a times during these time periods you have different rates of interest, and that needs to be taken into account while finding these equivalence cases. So, in those cases you will have to take into account the time during which a particular interest rate is applied. Now, that cannot be taken as the same as the next time also together, because they have different interest rates in those times. So, you cannot take altogether whole the suppose you have 4 or 5 zones, and you have some rate R1 here and some rate R2 and some rate R3 here. So, basically you cannot combine these two. This cannot be practiced, because in this time domain half is with the rate of interest R2, and and here is R3. So, you cannot combine them, you cannot take equivalent value something which is defined here, you cannot directly jump into this point, you will have to come to this point and then further you have to go to this point. So, this principle of the differential interest rates, different interest rates in different time, that must be taken into account, and for that the text is that as cash flows are converted to their equivalence from one time period to next, the interest rate associated with each time period must be reflected. So, while calculating this equivalent value, you must take into account the different interest rates which are there during the different times. Now, we can have one example of the such kind of case. Now, we can take an example of a cash flow where we see that you have suppose you have to find the p value, and you have different times 1, 2, 3, 4 and 5 here. Now, this is not the case. So, here we are not considering this case. Now, in this case what we see is that from 0 to 2 you have a rate that is defined, rate of interest R1, and this is defined as 12% compounded quarterly. And simply then you have between 2 and 3 you have R2 defined, and R2 is basically you have 7% compounded annually. Then between 3 to 5 you have defined this R3, and this R3 is 10% compounded annually. Now, for such cases, if you have to find the equivalent present amount, now what we see that from 0 to 2 you have 12%, and that is compounded quarterly. So, that rate is different. Now, R2 is 7% compounded annually. So, R1 is 12% compounded quarterly. Now, what you have to do is you have to find say the present amount or the future amount. Now, the transactions which are taking place is at 1 you have receipt of 200, then at 3 you have receipt of 100, and 3, 4 and 5 you have receipt of 100. So, if you try to see that what will be the value of p in such cases. Now, in this case, as you know that from 3 to 5 you have the same rate of interest being applied. So, from 3 to 5 you can have the value of the equivalent value can be calculated, but then you cannot apply. So, as you know that this is equal amount which is applied. So, your annuity concept is utilized. Now, you cannot use the p by a formula, because once you define p by a formula, that will be defined at one time ahead. So, it will be defined at time 2, and this cannot be possible because you have different interest rate which is occurring here, same interest rate is occurring here. So, basically you have to use f by a and I and 3. So, you have 3 transactions. So, 100 will be multiplied with f by a, and then rate of interest is also defined, and rate of interest R3 is 10.4. So, if you look at this, this will be 100 into f by a I3, and that will be defined at this point at 5th time period, and then it has to be mapped now it will be coming to here, then further you have to convert here, then it will come further to 1, and then it will go you can directly come from there because you have a one typically interest rate in between. So, what we do now the thing is that you can have the values like this, that you have f 100 into f by a 10 2s. Now, this another way what we can understand is, if you take this 200 transactions and use p by a formula, it will be defined here. So, you cannot take these 300 transactions and define use P by A formula, because that will go to this time step and you have different interest rate. So, you can use 100 and you can use these two to define present value at this point. So, you will be using P by A and the interest rate R3 is 10 and time is 2. So, this will be telling you the present value at this point. Now, this point you have already 100 rupees. So, this is 100 is added here. So, this will be defined at the point 3. Now, this point 3, now from here you have to come to point 2, and for point 2 it is compounded, this is 7% compounded annually. So, this is basically the future value and you have to go to the present value. So, you have to use the P by F factor. So, this will be multiplied with P by F, and that will be P by F and interest rate is 7 and this is for 1 year. So, this will be multiplied with this. So, this amount now you are coming to at this point. Now, you have to further bring this amount which is defined at 2 to 1, and this interest rate is different, that is 12% compounded quarterly. It means this is 1 year. So, there will be 4 times 3% of interest is added. So, you have to use the interest rate of 3% and time period will be 4. So, you will be multiplying with P by F, interest rate is 3 and time period is 4. So, this is what you are coming to this point. Now, further you are bringing it to this point. So, now you are P by A 3 4, you are coming to this point. Now, here you will add 200, because now you are defined, you are coming to this point where already you have 200 rupees of transaction. So, this is how you are now getting the equivalent amount at this point. Now, for finding the present amount, this is to be further you have to find the equivalent amount at 0 time. So, you will again multiply them with P by F 3 4. So, this is how you are going to take into account the different interest rates which are effective in the different time domain. So, as we see that you may have the different way to solve it. You could have calculated using F by A formula and then coming to, but again you have to come to this point. So, that is why we got using these two transactions, you got P here by adding 100 also plus to it, and then further finding here and then finally coming to these different interest rates. And if you are finding these values P by A tend to, you have to look into the different tables of the interest, and these values will be coming as 1.7355, then you will having the value as 0.9346, then you have 0.8885, and finally you have this also as 0.8885. So, ultimately if you do all these calculations, you are going to get rupees 380. So, basically this is how you are going to get these values of the present value for such cash flows, where in the different times you have different interest rates being applied. Now, if you have to calculate the future value for suppose this transaction, then your present value is known to this. So, you can go to, first of all you will go to this time. So, that will be multiplied with P by F by P factor with time will be 8 because it is compounded quarterly. So, I will be 3 and N will be 8, then you go to here further using again F by P formula and then further here. So, that way you can have the future values also calculated. So, this is one of the rule of finding the equivalent values. Next we have further in line the another equivalence principle, and that is equivalence between receipts and disbursements. Now, what happens that when you are dealing with a cash flow, then you have receipts and disbursements going on at different times. At some time you have receipts and at another time you have disbursement. Now the the equivalent receipt and equivalent disbursement, they must be equal. That is what the principle tells. So it tells that the actual interest rate earned on an investment is one that sets the equivalent receipt equal to equivalent disbursement. So the principle is that if you have you have some cash flow and the actual interest rate earned, now that will be the same rate of interest, that will be that particular interest rate earned, because of which whatever you have the receipts at different times. So receipts we normally represent in terms of positive quantities, and disbursements are represented by the negative quantities. So whatever receipts you have, its equivalent value will be same as the equivalent value of all the disbursements. So disbursement we take it as negative, but then their absolute values will be equal. So that if that is equal, then only we can say that there is actual interest rate which is specified, or the we call it as the attractive rate of return or minimum attractive rate of return. All that there are terms, or a rate of return or so. All these terms indicates about the rate of interest which is applied, and for that for the actual interest rate earned, the equivalent of all the receipt will be equal to the equivalent of all the disbursements. For example, if you take one example, suppose you have a cash flow diagram which talks about different disbursements which occur, and receipts also. You have altogether 7 time periods, 4, 5, 6 and 7. Now in that at some point of time you have receipts going on. So at 2, 3 and 4 there is a receipt, and receipt of 142 rupees each is going on, and then you have at 6 and 7 also there is a receipt of 142 going on, and at the 5th time you have a disbursement of 250 going on. So this is basically minus, because this is disbursement, so you are taking it as a negative value. And here at first time you have disbursement of 500 minus 500, and then you have here minus 1000. Now suppose for any particular cash flow, such is the transaction, you have the disbursement of 1000 at 0 time, 500 at first at the end of first time period, and 250 at the end of 5th time period, and receipts are at 2nd, 3rd, 4th and 6th and 7th time period. So if you have to say that how to see that whether you have the actual rate of interest earned, tells that this is this cash flow diagram is the actual representation of what is happening in actual case. So that can be checked by setting these values of the receipts and disbursements, equivalent values of the receipts and disbursements. Now in this case your rate of interest is shown to be 10%. So now you can check. Now what we do is we are going to calculate the equivalent value of all these receipts 142 which is there at 4 points, and then we are also going to get the equivalent value of all these disbursements. So the purpose is we can have the values equivalent values at any time, and the equivalent of all the receipts should be equal to equivalent of all the receipts at any particular time. Now let us say that we try to find the equivalent value of all the receipts and equivalent value of all the disbursements at suppose t equal to 5. Now at t equal to 5 at this point we try to find the net equivalent value of the receipt and disbursement. Now for this 1000 rupees its value will be future value at 5 time period away. So it will be multiplied with f by p 10 5. So this will be 1000 multiplied by f by p 10 5. 10% is the rate of interest. Then similarly you will have 500. So 500 again multiplied by so this is 4 you have 1 2 3 4 interest periods. So it will be again f by p 10 4, and then you have 250. So that is taken as the value of all the equivalent value of all the disbursements which is there. Now if you take all these factor values it will be 1.611 and this will be so 611, and then this factor value by looking at the table you will get 1.464 and this will be 250. So this is coming out to be 2593. Now you have to find the equivalent value of all the disbursements. So what we see is that this is basically not 142, this is 482. So this is not 482, and now what we see here that this 482 you can have the value at this point. So for this 482 its p by a and 2 time it will be defined directly here. So this 482 will be multiplied with p by a and rate of interest is 10 and 2. So this will be directly defined at this point, because once we use the p by a factor defines the present value at one time period previous. So if you take these two p by a values it will be giving you the value here. Now this 482 will be further taken into account. Now this 482 will be multiplied with suppose f by a 10 3. So it will be defined here, and then further you have to use for one time step away. So that will be 482 multiplied by f by a 10 3, and it will be also multiplied with so you have to get further its future value. So f by p 10 1. So it will be f by p 10 1. So if you take these factor values, p by a 10 2 is coming as 1.7355 and f by a 10 3 is 3.310. This you can refer it from the interest table, and f by p 10 1 is coming out to be 1.1. So if you do this calculation also it will be coming as 2593. So this is what you see that in the case of receipts and disbursements which is occurring at different times, if you are trying to find the equivalent values at any particular time, the equivalent value of all the receipts will be same as the equivalent value of all the disbursements. and their absolute values are equal. Otherwise, when we talk about finding the net values, we are going to have the consideration of its sign also, and this is how it can be shown. So that is what the principle of equivalence tells. Apart from that, there are also certain equivalence rules, like for any cash flow, if you try to find at a particular time of the two regions the equivalent values, then they will also be equal but with opposite sign. So that is also another equivalence rule, and that also can be checked and found to be correct. So these are the equivalence principles which must be taken into account, and when we will talk about the transactions at different time domains, that time these equivalent formulas will be useful for the calculation of different P, F or other financial parameters. Thank you very much.